So your first chapter is colloids. Definition of colloids. The term colloids mean glue-like substance. Colloids are dispersion, wherein dispersed particles are distributed uniformly in the dispersion medium. Definition of colloids. Colloid systems are defined as those polyphasic systems where at least one dimension of the dispersed phase measure between 10 to 100 Armstrong to a few micrometer. Example of colloids are milk, foam, aerosol, blood, fog, butter, and ice cream. Second, classification of colloids. There are four classification are based on the nature of interaction between dispersed phase and dispersion medium. Second, based on molecular size in the dispersed phase, based on appearance of colloids. Fourth is based on electric charge on dispersion phase. First, method on nature of interaction between dispersed phase and a dispersion medium. First is lyophilic, water loving, colloidal solution in which the dispersed phase has a greater affinity for the dispersion medium, means it has a great attraction towards dispersion medium. They are also termed as intrinsic colloids. Such substances have tendency to pass into colloidal solution when brought in contact with dispersion medium. If the dispersion medium is water, they are called hydrophilic. The lyophilic colloids are generally self-stabilized, reversible in nature, and are heavily hydrated. Examples of lyophilic colloids are starch, gelatin, rubber, and protein. Second is lyophobic colloids, mean water heating. Colloidal solution in which the dispersed phase has a no affinity to the dispersion medium. It means dispersed phase has no attraction towards dispersion medium. They are also referred as extrinsic colloids. The lyophilic colloids are relatively unstable. They are irreversible by nature and are stabilized by adding the small amount of electrolyte. They are poorly hydrated. If the dispersion medium is water, the hydrophobic colloids are called hydrophobic. Examples are soles of metal like Au, Ag, and sole of metal hydroxide and sole of metal sulfate. Third is associate colloids. These colloids behave as normal electrolyte at low concentration but behave as a colloid at high concentration. These associate colloids are also referred to as micelles. So, example, sodium citrate behave as electrolyte in a dilute solution, means a low concentration, but colloids in a high concentration. Example, soap and higher alkaline sulfonates. Based on molecular size in the dispersed phase. Multimolecular collides. Individual particles of the dispersed phase consist of aggregates of atom or small molecule having diameter less than 10 raised to the power minus 7 centimeter. The particles are held by weak van der Waals forces. Example, gold soul and silver soul. Second is micromolecular collides. The particles of dispersed phase are sufficiently large in size enough to be colloidal solution. They are called natural polymers. C. Based on appearance of colloids. Soles. When the colloidal solution appears as fluid, these soles are generally named as dispersion medium. When the dispersion medium is water, the sole is known as hydrosol. When the dispersion medium is alcohol or benzene, it is called alcohol and benzazole, respectively. Gels. When the colloidal solution appears as solid, the rigidity of gel varies from substance to substance. Example, jelly, butter, cheese, or curd. D. Based on electrical charge on dispersion media. Two electrical charge, positive and negative. When the dispersed phase in a colloidal solution carry a positive is called positive colloids. Example, metal hydroxide. And second is negative. When the dispersed phase in a colloidal solution carry negative, it's called negative colloid. Example, Ag-sol and Siv-sol. Separation of colloids, mechanical, electrical dispersion or Braytic arc method, baptization and condensation. First is mechanical. In this method, the substance is first grounded to a coarse particle. It is then mixed with the dispersion medium to get a suspension. The suspension is then grinded in the colloidal mill. It is consists of two metallic discs nearly touching each other and rotating in the opposite direction at a very high speed, about 7,000 rpm, that is revolution per minute. The space between the disc of the mill is adjusted that the core suspension is subjected to a greater shearing force, giving rise to particles of colloidal size. The colloidal solution of black ink, paint, varnish, dyes are obtained by this method. Second is by electrical dispersion or Braytic arc method. In this method is used to prepare soul of platinum, silver, copper or gold. The metal whose soul is to be prepared is made has two electrode which emerge in dispersion medium such as water, etc. The dispersion medium is kept cooled by ice and an electric arc is struck between the electrode. The tremendous heat is generated by this method is called colloidal solution. The colloidal solution prepared is stabilized by adding a small amount of KOH to it. Third is by baptization. The process of converting a freshly prepared precipitate into colloidal form by adding a suitable electrolyte is called baptization. The cause of baptization is the absorption of ions of electrolyte of the particles by the particles of the precipitate. The electrolyte used for this purpose is called baptizing agent or stabilizing agent. The important baptizing agent are sugar, gum, gelatin, and fourth is condensation method. In condensation method, the smaller particles of dispersed phase are aggregated to form larger particle of colloidal dispersion. Dimension. Last is purification of colloids. There are three common methods used for purification of colloids. They are dialysis, electrodialysis, and ultrafiltration dialysis. Its principle is that colloidal particle cannot be passed through the cellophane membrane, but the ions of the electrolyte can pass through it. The distilled water is changed frequently to avoid accumulation of crystalloid, otherwise they will start diffusing back into the bag. The dialysis can be used for removing HCl from the ferric hydroxide sole. Second is electrodialysis. The process of dialysis is very slow. The process is speeded up by application of electrical potential. This is called electrodialysis. Third is ultrafiltration. Is a process of high pressure filtration through a semi-permeable membrane in which colloidal particles are retained while the small size solute and the solvent are forced to move across the membrane by hydrostatic pressure force. Ultrafiltration is a vital process that takes place in the kidney.